And here we go.
There's the deluge. Here's ignition.
Roger, roll, Atlantis. Doubling up.
Did you just do a Kerbal?
Back to the moon and beyond.
Put that in the big bag, Gino.
Back at home, we all have a lot of work to do, but from here, it sure looks like a perfect world.
Propulsion continues to be normal.
We did have an observation.
343 unfolds to go.
It's orange.
Water towers can fly!
Bingo! Right in the center.
Where's Jacqueline? There it is!
That was surreal.
That's not what we want to see.
No!
Oh my god.
Yikes, you bet. Sure. We don't need any more of these.
Well, hello everybody. It's time for another NSF live stream, this time coming to you live from the Guiana Space Center in French Guiana. And Ariane 6 with its 2 SRBs is vertical at ELA 4, excuse me, with MTG-I2, a brand new weather satellite inside of that payload fairing. My name is Ryan Caton. Thank you very much for joining us for what is hopefully going to be a very beautiful countdown. You can already see golden hour almost starting there on the left-hand side of the vehicle. We are approaching sunset within the next couple of hours in this part of the world, so fingers crossed we do get some very pretty views indeed. But of course, it's not just my voice you're going to have to listen to over the next hour or so. We also have Marty joining us, as usual, for some more European space domination. How are you, Marty?
Hello, Ryan. Hello, everyone. Good to be back on stream with you. And it's certainly good to have another Ariane 6 on the pad, ready for launch. You know I love these launches, so I'm ready to see it go.
Absolutely. And don't forget, if you have any questions or comments for us, tag us in chat at NASA Spaceflight or at NSF, and we will do our best at answering them because, you know, we don't get an Ariane 6 launch every day of the week. It is a little bit rarer than the Falcon 9s, but that being said, they are a little bit more, the cadence is a little bit higher than some may have expected only a few years ago, because this is already the 4th mission of 2026, which means, you know, if we're in August, they're averaging a launch of these every couple months, which for an expendable launch vehicle that isn't reusable, not too bad, I'm going to say, not too bad. Definitely could be worse. Vulcan, but swiftly moving on. First of all, Marty, I'm going to hand it over to you because if you would mind giving us a little rundown on what we are expecting to see in 56 and a bit minutes' time.
For sure, for sure. So this rocket on the pad is an Ariane 6 in its Ariane 62 configuration. So 62 means that it has 2 solid rocket motors, and in this case they are the P120C solid rocket motors. That's the not upgraded version. If you remember last Ariane launch, when it launched a batch of LEO satellites for Amazon, they did fly in the upgraded configuration, but this is not that configuration. It is not the rocket's most powerful version, so no need to upgrade it with more propellant and more thrust. Anyway, inside the fairing, this is the short version of the fairing. It's clearly a small satellite. The 14-meter version of the fairing is the MTG-I2 satellite. That is short for Meteosat Third Generation Imager 2, or also known as Meteosat 14. The payload mass is 3,800 kilograms, and that includes 2 tons of propellant. So I already said that this was quite a small satellite, and in its stowed configuration, which it's stowed right now, like solar arrays folded up and everything, it measures 2.3 meters by 2.8 meters by 5.2 meters. So it fits well inside that 14-meter long and 5.4 meter diameter payload fairing that's on top of Ariane 6 right now. I already told that the payload is fully fueled with 2 tons of propellant, and that will allow for a lifespan of 10.7 years, although the minimum lifespan that they're hoping to get out of this satellite is 8.5 years. I suppose they just have a few years of extra propellant just in case the satellite is healthy and ready to continue on for a few more years. But yeah, after 10.7 years, just over a decade, this satellite should be over and out. Anyway, they've got a lot of time to operate that satellite until then. And what it's going to do? Well, this satellite is launching into a geostationary transfer orbit, meaning that from this pad in South America, it will be delivered to a geostationary transfer orbit, an orbit that brings it into a path so that the satellite can raise its own orbit to geostationary orbit. And from that perch in geostationary orbit, it will use its imaging capabilities to study the atmosphere. Specifically, it will take high-resolution images of the atmosphere above Europe and Northern Africa every 2.5 minutes, and meteorologists will use that data to predict weather and do all the kinds of things that you want to do to make sure that you know what kind of weather is coming up. Is there anything I didn't talk about? Yeah, the customer for this mission is EUMETSAT, which is the European Organization for the Exploitation of Meteorological Satellites. That's a whole mouthful. And in true European fashion, like that's just one international organization taking some responsibility for this mission, but it's not doing that alone because, like I said, it's all organizations collaborating. So the satellite itself was actually developed by the European Space Agency, or ESA, and they don't build their own satellites, so they hired Thales Alenia Space to actually build the spacecraft. Very complicated structures as we're used to here in Europe. Yeah, I think that is pretty much all I can say about this launch at this time, but I'm sure there's loads of stuff that I've skipped over. So come in with those questions and we'll see what we can answer.
EUMETSAT is definitely one of those organizations which is, it's like ESA, where like it's not tied to the European Union because there's member states of EUMETSAT that isn't a member state of the EU, like the UK. We don't need to get into that right now. Same with the European Space Agency. Like, I think technically Canada and Mexico are somehow part of ESA in some capacity. I'm not sure how that works. Yeah. But I mean, Australia's in Eurovision, so I'm sure it's fine. It's very interesting how there's so many different international organizations that all come together and they all kind of have a stake in it. Because it's hard to say, like, who is this satellite for? Well, it's done by ESA, but they contradict to Thales, but it's actually for EUMETSAT. Like, there's so many different parties involved in just doing a weather satellite.
Mm-hmm. And just to answer your question about Canada and the European Space Agency, Canada is actually an observing member and not an actual full member state. So that means they do have some powers, but like not the full powers that like the UK or France or Germany or the Netherlands have.
I've got some questions coming in, so thank you very much. First of all, we're going to start off with Marcus, who is asking, where is French Guiana? We need a map. Well, good for you. We have a map, a very useful map, because it isn't just a map. It includes the hazard zones for this launch. We have 2 different... There we go, zooming out a bit. That's more useful for you. Got the little location identification marker pin. That's the word I was looking for, the pin. Look at me coming up with fancy words. It's a pin. So there you go. You can see in South America on the north coast in French Guiana, in Kourou. You can see Brazil there and I think Colombia also labelled. So we're going to the east for this launch, which of course makes sense considering this is a geostationary transfer orbit mission. So Ariane 6 is going to send the satellite on a transfer orbit. It'll then make its own way into that final geosynchronous orbit, which is where it'll be monitoring the weather on Earth from. And that's also an advantage of the Guiana Space Center because it's about 5 degrees above the equator. So I think unless you want to air launch or sea launch, this is the closest orbital spaceport in the world to the equator. And of course, as we all know, the closer to the equator you are, the faster you will be spinning because Earth is round. Fun fact, compared to the poles, which means you get a free little kick, free little boost from the Earth assuming you're launching towards the east, you get a free little boost to get into space. How handy is that?
Very handy.
Let's see here. We have another question. This one from MCC Saxman, who is asking how many Ariane 6 flights have been completed or have occurred this year. How many are still planned for the rest of the year? Marty, I'm sure nextspaceflight.com, also available in the Google Play Store and iOS App Store, is very useful for this particular question.
It certainly is. And when it comes to these kinds of questions, Next Spaceflight, our app and website, is certainly the first place I would go to answer them. But I already had the stats in front of me, so I don't even need to go there. This is the fourth Ariane 6 mission of the year. And it is actually the sixth Ariane 62 launch, so in its 2 booster configuration, and the 9th total since the first flight in July 2024. It's also the 9th Ariane 6 flight from this very launch pad. But guess what? They built this pad for Ariane 6, so that should be no surprise. Looking at the future in next spaceflight, I think that's quite interesting because for the rest of the year, we've got 3 more missions scheduled. Like one of them is specifically scheduled for October. It will be another Amazon LEO mission. And there are 2 more missions scheduled in no earlier than the 4th quarter of 2026. Of course, we need to see whether the specific date will materialize within this calendar year. But if they fly as scheduled right now, they might be able to get 7 missions in this year, which will be a launch rate of just over 2 flights a month. Sorry, that's not correct.
Other way around.
The other way around, yeah. A flight in under just 2 months. That you get what I mean. So yeah, that's quite a nice increase in cadence from the last couple of years. And I do remember that when they got a new CEO a few years ago, his priority was actually to increase the Ariane 6 launch rate. And so far, it seems like they're succeeding at that.
I feel like the Ariane feed may not be showing what they're meant to be showing right now.
This is not live from our studio, by the way.
No, I'm going to give them the benefit of the doubt, and we can look at the VAB for a moment because I'm not 100% sure if they intend for that to be broadcasted live. But would it be an Ariane stream without something happening? So we will. Oh, we've got the rocket back. Never mind, everybody. We've got the rocket back. Don't panic. Crisis averted. Okay, swiftly moving on. We can edit that bit out. Robert Collinson, thank you for becoming a Red Team member. And do remember, if you have some questions related to the rocket and not the Ariane Space livestream studio, do tag us in chat at NASA Space Flight or at NSF, and we will answer them. The Country Cooks is asking, I'm not sure whether they're, because it is a bit of a joke question on NSF now, or whether they are seriously asking the question, but we can seriously answer the question. They're asking, what are the 4 towers for? And Marty, just like Florida, French Guiana has seen a storm or 2 in its time.
It certainly has. Yeah, this is, well, French Guiana and the spaceport specifically is right on the edge of a rainforest, like the tropical forest. So yeah, it's in the name, rainforest. So yeah, it has seen, definitely seen a storm or 2, and thunderstorms are not out of the usual there. Although we have seen some launches that got struck by lightning and just proceeded normally. Quite recently, there was a Changchun launch from China that actually managed to do that. But that is a very rare occasion. Usually when rockets get hit by lightning, things go sideways very quickly. So you want to avoid that. And you even want to avoid hitting the rocket with lightning when it's out on the pad. So these towers, and there are multiple things visible on the screen, but on the sides of the screen, you can see these truss-based towers. They actually hold up the lightning protection system. That's a system of wires that will be used to protect the rocket on the pad and the ground infrastructure from lightning. And if there's a lightning strike nearby, it will hopefully hit these wires and not the rocket. I believe when Artemis 1 was on the pad, we actually got a picture, or someone got a picture of the lightning protection system protecting the SLS rocket. Correct me if I'm wrong there.
Certainly a proven system to help stop rockets from getting electrocuted.
Absolutely. And while we're talking about the buildings on the screen, I guess it's good to talk about the building that's right behind the rocket as well. Because normally during these Ariane launches, we get questions about that. Right now, it seems like the building is very, very close. But actually, it's a lot more distance than it seems on screen. I guess the lenses do a bit of compression there. The rocket was actually assembled in that building, and then I don't recall which way it goes. For some rockets, it's the building that moves out of the way, and for other rockets, it's the rocket that moves out of the building. And obviously, Arianespace has chosen either of these strategies. But no matter what, the building is out of the way and actually quite a distance removed from the rocket. So it should be safe and well protected from the rocket exhaust at liftoff. And even if it isn't, the building is built to be next to a rocket launch, so it should be able to withstand that.
Yeah, I'm pretty sure. Don't quote me on this, but I'm pretty sure that the building moves because the launch pad, the mount itself appears concreted in, but I don't actually know that for certain. I think it is the building that moves.
I'm sure that ULA for Atlas and Falcon does it the other way around, but I believe Ariane does it indeed with the building moving out of the way, which is now confirmed by Alex in the back channel. Thank you, Alex. But always a risk to get these things wrong on stream, and we don't want that.
Same with the Delta 4. Rest in peace, the Delta 4. That's its support building. It was built in the building on the pad, and then the building moved back at Slick 37 and Slick 6. Both have now since been destroyed. Sad times. We can cheer ourselves up with a rocket launch in 42.5 minutes' time.
Let's do that. I'm looking forward to it.
Slightly different, of course, to the Ariane 5, which, of course, was built a little bit further away, and then they have plenty of rail systems in Kourou, and it's pretty cool to see. Sometimes they'd live stream it, but you could see the entire vehicle stack and its launch platform, like literally being trained from where it was built over to the launch pad. I'm pretty sure they streamed that for James Webb, which is where I'm remembering that footage from, but slightly different process for Ariane 6, of course, a bit more of a modern rocket compared to Ariane 5. Let's see here for some more questions. Interesting question from Jay Abram, but we can talk about the specifics of the vehicle nonetheless. They are asking, is that rocket as tiny as it looks? And Marty, Ariane 6 might be a little bit shorter than Falcon 9, but it's still pretty beefy.
It still is. It's still a very powerful rocket, and part of the reason why it's shorter is also because it's wider. But just to run the numbers here, the main stage, which ends, I think, between the 6 and the ESA logo, and there's probably an interstage somewhere in there as well. But the main stage is 32 meters tall, and then the second stage, the upper stage, is 9 meters tall. And the fairing on top is 14 meters. There's also a 20-meter longer version of the fairing. So just running the numbers on top of my head very, very quickly, that so
you've done a rookie error, which is doing maths live on stream. It's never a good idea. I mean, you are from the get-go. You are setting yourself up for failure, Marty.
Yeah, the pressure, I cannot handle it. I do have to retreat to a calculator right now, because I should be able to do this calculation off the top of my head and get to the number of 55. But for some reason, the pressure of all these people listening to me speak has overcome me, and now I cannot do math anymore. But yeah, the total stack, the total rocket, this rocket is 55 meters tall. And would you stack the 20-meter variant of the fairing on top of that, it would be 61 meters tall. But that's not this configuration. So 55 meters tall, which is just a smidge taller than a Falcon 9 booster, I believe. So yeah, it's definitely not the tallest rocket, but it makes up for that in width, I suppose, because it's 5.4 meters wide, the diameter of the fairing and the booster itself, whereas Falcon 9 is 3.67 meters wide.
Falcon 9, of course, skinny, so it can fit under all the different road bridges between Hawthorne and Florida. It is trucked across the country. Ariane 6 is boated across the Atlantic. Shipped, that's the word I'm looking for. Shipped across the Atlantic. Built in mainland Europe, launched from French Guiana in South America. And, of course, all the final assembly taking place inside of that building behind the rocket. Under 40 minutes. Go on.
It's just a matter of requirements. Ariane 6 doesn't need to fit on the road bridges. So, yeah, they can make it a bit wider. And the same, for example, for Rocket Lab's Neutron.
Indeed. Although they did ship the Hungry Hippo fairing over the bridge at Wallops, and that was pretty crazy to see because it's wide. I'm pretty sure that the Hungry Hippo itself is wider than the bridge it was being trucked over. Micah got some pretty cool pictures of that in Wallops.
I think you might be right, yeah.
So we're now under 39 minutes to go until launch. Of course, this is a cryogenically fueled vehicle, hydrogen and oxygen across both stages. And Richard Evans is asking, has fueling started? It's difficult to see, Marty, but we are getting some wisps of vapor from the top of the second stage. So it's pretty easy to visually confirm that indeed it has.
I believe so, although I have to admit that my version of the stream goes very low bandwidth every now and then, so I can't really see much. But the 2 pixels I can see of the first stage seem to be slightly fluctuating. So that's certainly a sign of some cryogenic fluids being in that stage and some condensation and colder air being moved along. So yeah, I do believe that the rocket is fueled or being fueled right now.
Thankfully, it got a little bit of wind to help move that vapor around and make it a little bit more visible, even if it is very small on our preview. But it is there. Of course,
it certainly is.
Ariane 6 is insulated, so it's not like Falcon 9 where we get that huge frost line. Even if it wasn't insulated, it's painted white, which would make the frost a bit more difficult to see against the sooty colour that the Falcon 9 first stage booster is. The Ariane 6 booster does get a little bit sooty after its flight, but unfortunately, it doesn't come back to the launch site or land downrange. It ends up in the Atlantic Ocean. It's become a new coral reef. And one word of notice, one parish notice for today's mission. Unfortunately, Arianespace will not be providing any onboard live views from the vehicle. So we will only have the ground-based tracking asset, or at least we're not expecting any onboard views. If they accidentally show us one, then I'm not going to complain. But we are expecting only the ground-based tracking assets for today's mission. But it should give us a spectacular view nonetheless. Of course, the onboard views with Ariane 6 are a little bit delayed to real time anyway, so shouldn't be taking anything away from the launch, but just a word of notice. If we were expecting some onboard views, we are not expecting them today. 35 minutes, 50 seconds left to go in the countdown until today's launch. I'll just say it again, as more people will be joining us throughout the minutes as we tick down. We've just gone past 4:30 in the afternoon local time in Kourou, French Guiana, which means we are approximately 2 hours away from sunset. So come the time of launch, we will be about 90 minutes away from sunset. So hopefully, once again, we will get a very pretty golden hour launch of Ariane 6. And Marty, of course, as the sun gets lower on the horizon, that means the SRB plume should become more visible against the sky, because as the sun gets lower, the sky gets darker, but the plume will still be illuminated because it will be going higher. Physics.
It should, yeah. And that's actually an interesting thing you're talking about here, because the core stage of the rocket is fueled by hydrogen, which burns very, very clear. So if we were just launching the core stage, we aren't, but if we were to do that, then the plume would be almost invisible. But the solid rocket boosters, they burn solid fuel, which usually results in a very, very dense smoke, which is very, very visible out of the exhaust. So there's an entire trail going up following the path of the rocket. And indeed, if it's lit by a low sun against a dark sky, these stand out very, very much and become very visible.
And speaking of the viewing conditions, Matt K12 is asking, weather looks good, right? I mean, looks visually quite nice. We've got some clouds in the background, but we've got blue skies over the vehicle. Unfortunately, we don't have, like the 45th Weather Squadron in Florida. They give a little report ahead of each launch. Unfortunately, not something like that for this particular launch. But I mean, I think you can tell for yourselves the weather is looking pretty good above Ariane 6 right now. And fingers crossed it continues to stay that way over the next 33 minutes and 40 seconds until launch. We also have Siva Hamlin. Thank you for becoming a Red Team member as well. Got a few people becoming members during this stream, so hopefully you enjoy all of the behind-the-scenes photos and other perks that you get in the YouTube member area. Of course, Capcom and above, you get access to our Discord server as well, so plenty of shenanigans go on in there, as we can all attest to.
For sure. Yeah, it's a very fun space with all kinds of discussions, sometimes more serious, but definitely a lot of fun.
Sometimes more serious than others. M Company Space is asking, good question, because it means we get to talk about orbits. Always fun to talk about orbits. If you are under a geostationary satellite, is it always in the same spot in the sky? Marty, that is kind of the primary concept of a geostationary satellite, but it's not as easy as just saying, don't move.
Yeah. Yeah, pretty much. So the thing is, with orbital mechanics are quite complicated, but yeah, like every satellite takes a leap around the Earth, even the geostationary ones. It's just that for the geostationary ones, the altitude is just right, that the velocity they need to go matches up with the spin rate of our own planet. So our planet spins around its axis, that's why we have day and night, and then the geostationary satellites are in just the right place to be constantly above the same place. But they can only do that if they're at a 0-degree inclination. That means that they are just directly above the equator. If they're not, then they will, like, kind of from our perspective on the ground, just go in a straight line up and down. That's just how these things work. And that we call that geosynchronous orbit. So same altitude, but just a slightly different inclination, which means that these satellites are not always in the same place. Anyway, this satellite, the MTG-I2, is going to a geostationary orbit. So once that is in its destination orbit of, at the geostationary altitude at 0 degrees inclination, it will always remain in the same place. And I don't know if you've ever set up a satellite television, but when you do that, you usually also connect to a satellite in geostationary orbit, which is very useful because you know exactly where to point your satellite dish to. And if you know where that satellite is, you can just like use a compass and point your satellite dish. And as long as there are no trees in the way, be assured of a signal. So that is how this geostationary orbit works out. But of course, this satellite is not really looking to talk to a television. Instead, it's looking to take images of the same part of the Earth every time. In fact, every 2.5 minutes, it will take high-resolution images of the atmosphere above Europe and Northern Africa, which meteorologists will then use to predict storms and all that stuff and make sure that we're ready for all kinds of weather events. So that's a very good reason for a satellite to always be in the same place, just so you can take these same images over and over and over again, and use the data to compare and predict and forecast and all that kind of stuff.
Of course, weather forecasting becoming ever more useful in this part of the world. I think in the UK, at least, we've had like 4 heat waves since May. And as a Brit, we don't do the heat well. So learning more about the weather is only a good thing, in my opinion. Because, yeah, plenty of heat waves this summer in 2026. Luckily, it's been a little bit cloudy and a little bit rainy over the last few days. Got a little bit of a rest from the intense heat of the peak of summer.
For sure, yeah. Well, over here it's just a bit hotter inside than usual, so but I had to close my windows for good audio. So the offers I make to be on stream.
The sacrifice is worth it, though. Again, if you are just joining us, we are under half an hour now, almost under 29 minutes until the launch of MTG-I2 on this Ariane 6 from Kourou in French Guiana. If you have any questions for us, do tag us in chat at NASA Spaceflight or at NSF. And we will do our best to answer them, as we have been doing over the past half an hour or so. Next question in the queue comes from Derpinator95, brilliant username. First Ariane launch, congratulations, hope you enjoy it. What are the timings and how does it differ from SpaceX? Well, Marty, unfortunately, I don't think we have too many details on the timeline before launch, but we do have details on the timeline after launch. So I was just wondering if you want to read us through what we're expecting once the Vulcan 2.1 ignites.
Yeah, exactly. Well, before launch, there are a few differences still that I can talk about. For example, Falcon 9 is loaded. Apologies. Falcon 9 is loaded just before it flies. So they do this last-minute loading thing. And I believe that they're not doing it to that extreme with Ariane 6. But yeah, other than that, we don't have that much information about the pre-launch countdown for Ariane 6. What will happen in just under half an hour at T-minus 7 seconds, just 7 seconds before liftoff, the Vulcan 2.1 engine will ignite. So that is the singular hydrogen-powered engine on the core stage. So that will, ignite for a few seconds, and once they know that that's running okay, they will actually ignite the P120C solid rocket boosters. And once these two are ignited, well, there's no stopping. The rocket has to go. So that's also when you will see a liftoff at T0. And at that point, the rocket is still at 0 kilometers in altitude. But just 2 minutes and 15 seconds later, it will be at 61 kilometers, which is when the solid rocket boosters will separate. Then at 3 minutes and 31 seconds, at 109 kilometers, the fairing will separate. And comparing to the Falcon 9 countdown, this is actually very interesting because at this point, the core stage is still firing. So the core stage, the main stage, will actually fire for almost 8 minutes, and stage separation will happen at 7 minutes and 49 seconds into flight when the rocket is at 196 kilometers. And if you're following a Falcon 9 launch, by that time, the Falcon 9 booster, the first stage, is already well on its way back and almost ready to land on either a landing pad, landing zone, or a drone ship. So very big difference there, but it will get this Ariane 6 to orbit. Because then, after coasting for 4 kilometers or just under 10 seconds, the upper stage will ignite, and that one will also fire for a very, 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 very long time, because it will only extinct at 21 minutes and 28 seconds into flight. So that's like after 13.5 minutes or so. Then at T plus 36 minutes, the payload will separate. I'm not quite sure why they're waiting like 15 minutes for payload separation, but it's not too egregious either. And for that will definitely be the end of this Ariane 6 mission, but not quite, because at 1 hour and 40 minutes into flight, the upper stage will do some maneuvers for passivation. So you might remember that one of the upgrade introduced on Ariane 6 was an APU, auxiliary power units, or no, there was a different abbreviation for that because they like to be confusing. which I
Probably
have
like
forgotten.
UAP or something in French. They just take the same words and reorder them for no reason whatsoever.
Either way, that device was supposed to bring relight capability to the Ariane upper stage, but they're not using that for this specific mission. Instead, they will just pacify the upper stage and put it into a graveyard orbit, I believe. Or they will let it decay naturally, because the orbit this upper stage will be left in is 250 kilometers by 35,666 kilometers at 6 degrees inclination. That's the geostationary transfer unit. And Alex in the back channel with the abbreviation I forgot. APU in aviation is auxiliary power unit, but for Ariane 6 it's auxiliary propulsion unit, which is indeed the propulsion unit needed to, I believe, to settle the propellant so they can actually relight that upper stage.
Indeed. You certainly don't want to start an engine with your propellant kind of floating all over the place. That wouldn't be not a good thing for a rocket engine. Let's just put it that way, as we've seen before.
That would be a bad day in space.
Yeah. Of course, one of the benefits of launching from Kourou in French Guiana, as I was talking about earlier, is we're just 5 degrees above the equator here. So, for all intents and purposes, we're on the equator in French Guiana. And that means even though the upper stage, as we've seen with the Amazon Leo launches, the last couple of flights that Ariane 6 has flown, it's a bit low thrust compared to, your Falcon 9 second stage. But because they're launching from the equator, they only have to do one burn to get to a geostationary transfer orbit with that upper stage. They call it the Upper Liquid Propulsion Module for some reason, ULPM, because they like giving everything fancy names. Of course, the booster is not called the booster, it's called the Lower Liquid Propulsion Module, or ALPM, which is a bit of a mouthful, so we just like calling it the booster, because everybody knows what the booster is. But they can get away with just doing one burn to deliver MTG-I2 on its geostationary transfer orbit, which, for example, if this was launching on Falcon 9, you would have to do an initial parking orbit, wait until Falcon 9 is over the equator, and then do an inclination change to get it into that GTO headed up to 30-odd thousand kilometers, which is where this satellite will be spending the rest of its life. Hopefully beginning in 22 minutes and 30-odd seconds. Let's see here. As a reminder, if you are just joining us and you have any questions for us, tag us in chat at NASA Spaceflight or at NSF, and we will do our best job at answering them. Simple question here. What Z90 is asking, how heavy is MTG-I2, the payload Ariane 6 will be launching today? Marty, very usefully, this is also something readily available on nextspaceflight.com, also available on the Google Play Store and iOS App Store.
Of course, yeah. This information is listed in on our website, nextspaceflight.com, and Next Spaceflight has it at 3,760 kilograms, which is actually more precise than the Arianespace provided press kit, which only has it at 3,800 kilos. So yeah, for the better numbers, go to nextspaceflight.com. But what I do know from that, from the official information from Arianespace, is that the mass I just mentioned includes about 2 tons of propellant. So it will use, it's more than half actually of the payload mass is propellant, which it will eat up throughout its mission, which is said to last for a minimum of 8.5 years, but it has fuel for 10.7 years. So it's a bit of wiggle room to either use some more fuel than planned, or to extend the mission by a couple of years if fuel reserves allow.
Of course, that's something you would always expect with a rocket, because at the end of the day, a rocket is essentially just a giant tube full of as much propellant as possible. That's why we have dry mass, which is the weight of the rocket, or the mass of the rocket, I should say, just the rocket components, and then wet mass, which includes the mass of the propellant, because it changes by such a significant amount. Because, I mean, it's a 60-meter tall rocket. It's going to be full of a bunch of liquid hydrogen and liquid oxygen. So, it's going to have some significant mass to it at liftoff. But of course, by the time we get to stage separation, the vast majority of that will have all burnt away, which is kind of mind-boggling to get your head around.
Fun fact, most of the mass we see on screen right now is designed to lift other propellant, to lift other propellant, to lift other propellant, to lift a payload or something like that.
And even in that case, the payload has propellant, which is designed to lift the payload. So it's kind of many layers of onion skins all come together to launch a rocket, if that makes sense.
It does. It's called the rocket equation.
Slightly unrelated question, but it's a question about rocketry anyway. So, of course, we do cover Starship quite extensively. But Daniel is asking, will we be covering the Forte ship carrying Starship's journey home? I can assure you that we will, in our weekly Starship update videos, be closely following what Starship is up to. We have been ever since Ship 40 made it back to the Indian Ocean in one piece, which I'm still utterly shocked that happened, considering every single other Starship has blown up, because, you know, it's a 50-meter tall rocket tipping over onto the water. I mean, what else do you expect to happen? I mean, it's almost a fact of life that it's going to explode, except Ship 40 didn't, which was very impressive. But we will be covering this, so do subscribe and do the notifications and everything, because every Monday, Starship Update, as we call it now, brings you the latest on all of the happenings with Ship 40. Speaking of mass, Marty, we have a question from Vertical Guy 1, who is asking, how much fuel does the first stage of the rocket have? I don't know if we have that specific number, but I think you do have a number on the overall rocket.
Yeah, I do have a number. According to Arianespace, the lift of weight, the lift of mass of this, the entire stack is about 500 tons. And as always, Alex coming in with the precise numbers for the first stage. The main stage, first stage, core stage, whatever you want to call it, or I believe you just had a different name for it, Ryan. But that thing...
The lower liquid propulsion module, because we like to be fancy.
Fancy indeed, yeah. Anyway, that thing houses 154 metric tons of liquid hydrogen and oxygen. So, yeah, I don't know the exact mass breakdown, which is mostly dictated by chemistry. But, yeah, a total of 154 metric tons of liquid hydrogen and oxygen in the first stage. And apparently, the upper stage has 30 tons of fuel. Or propellant, I suppose.
Of course, oxygen and hydrogen have very different densities, especially when in liquid form. So that's something we're always very keen to keep an eye on when we're talking about the Space Launch System and its troublesome tail service mast umbilicals with leaky hydrogen all of the time. Not all of the time. It did a pretty good job on the launch attempt for Artemis 2. Have to give it credit. But hydrogen, definitely one of those less dense elements, compounds. I wasn't very good at chemistry. Forgive me. But it's definitely much less dense than your oxygens, your methanes, your kerosenes, etc.
It sure is. And it's also very hard to contain. But Arianespace clearly has that down to science, because they have managed to launch this thing on a regular cadence now without hydrogen, as far as I'm aware, without hydrogen causing many troubles.
On a similar note, we have speaking of weight, Reed Trimmer is asking, how high is the initial thrust to weight ratio of this rocket? I've seen it immediately shoot upwards in some launches. I don't know if we have a specific number, but I mean, it's high for an orbital rocket. This thing, especially when it's in its 4 SRB configuration with the upgraded P160C motors. I mean, we saw it on the previous flight. That thing just leapt off the pad, and it almost did like it started its roll program and orbital pitch over almost like a missile. It was like up and sideways, headed immediately downrange. I mean, the turning on that launch was just incredible. Slightly less impressive on the 2 SRB configuration, of course, because there's less SRBs. But
yeah, but still, this configuration with its 2 SRBs has a lift of thrust of approximately 8,000 kilonewtons. So if you know your physics, you would be able to calculate the thrust to weight ratio from 500 metric tons and 8,000 kilonewtons. But like we have established already, I'm not going to do maths live on stream because that's not ending well.
Maybe about 2. There you go. Good enough.
Yeah, close enough. Yeah.
Okay. As a reminder, if you do have any questions for us, do tag us in chat at NASA Spaceflight or at NSF, and we'll do our best to answer them. We are now under 15 minutes until the launch of MTG-I2, which is a brand new weather satellite for EUMETSAT. Marty, we do have some people joining us now that weren't with us at the beginning of the stream, so just as a reminder for everybody, would you mind quickly going through kind of the top fun facts of what we're expecting to see launching today?
Yeah, for sure. So in just under 15 minutes, just over 14, we're expected to see this Ariane 6 in its 62 configuration launch, which means that it has 2 solid rocket boosters, frustratingly not quite aligned with the logos and everything on the vehicle, but we'll forgive them for that because the rocket launch itself will look very, very awesome. Anyway, this rocket is outfitted with a 14-meter fairing, which is the short version of the fairing, and inside that fairing is the MTG-I2 satellite, which is short for Meteosat Third Generation Imager 2. It's a satellite massing just under 3,800 kilograms, and yeah, it's a fairly small satellite. It's only 2.3 meters wide by 2.8 meters by 5.2 meters in its stowed configuration. But of course, that's its stowed configuration, so it fits inside the fairing. Once in space, it will extend its solar panels and all that. It will be a bit bigger than that. Anyway, the customer for this mission is EUMETSAT, which is the European Organization for the Exploitation of Meteorological Satellites. Shouldn't try to talk too fast because then I'm stumbling over these words. But yeah, that is an international organization that made up of several organizations within the European countries that exploit these weather satellites and use the data and use it to predict, forecast the weather, I should say. And in this specific case, the satellite will be delivered to geostationary transfer orbit, from where it will transfer itself to geostationary orbit, I should say, the right orbit. So it means that it's always above the same point on Earth's surface. And from there, it will have a look at Europe and Northern Africa, taking high-resolution images every 2.5 minutes, which will be used to forecast storms and measure them in real time and everything. So hopefully we'll be able to avoid disasters with all this kind of information. But EUMETSAT is not working on this alone. The satellite itself was actually developed by the European Space Agency, ESA, and they handed manufacturing duties over to Thales Alenia Space. So just, yeah, in 11 minutes and 40-something seconds, we will see this Ariane 6 rocket ignite its engines and lift off the pad to deliver that very payload into geostationary transfer orbit.
Looking good so far. We have been noticing, I will say, there have been loads of birds flying in front of the camera. Jab the Ram in chat has said, is this next to a bird sanctuary or something? There are so many. I don't know if it's like an officially protected wildlife place like Cape Canaveral is, but we are on the edge of the Amazon rainforest here. Like, this is one of the most diverse, at least biologically wise, one of the most diverse places on the planet, right on the northern edge of the Amazon rainforest. So I'm sure you're bound to find some interesting wildlife.
Yeah, it sure is. So that's the reason why we're seeing all these birds. There's probably many more animals out there who will be unpleasantly surprised with the launch in just a few minutes. But such is life, I guess, for a bird at the Kourou Space Center.
Could be worse. You could be a bird that lives at Space Launch Complex 40 or Slick 4 East in Vandenberg.
Oh, please no.
Fortunately, they are unable to file their noise complaints because, Anyways, fingers crossed we do indeed get a launch in 10 minutes and 10 seconds time. Beyond this point, we usually, we have the famous T-minus 20 minutes and 20 second vent on Falcon 9, where they clear out and purge the lines as they prepare for oxygen loading. Scott is asking, why don't we see the LOX venting like we do on Falcon? And Marty, I think it's just because their propellant loading sequence is going to be differently timed. It's a hydrolox vehicle. We do see some vapors, and different rockets are built differently. They're not necessarily going to have a huge, thick liquid oxygen vent coming from a strongback. If you could even say that Ariane 6 has a strongback.
Yeah, you're totally right. Every rocket has its own launch sequence. You also see plenty differences between Falcon 9 and Starship, for example. Completely different vehicles, different propellant chemistries, different designs. And yeah, just because SpaceX has decided to clear out their lines in a way that is very, very visible to us, that doesn't mean that Arianespace should do the same. And in fact, they have a completely different heritage, which probably also means that they have different methods for doing these things, which results in very different visuals from our perspective. And I've just said the word different a whole bunch of times.
I'm just receiving word that we have an update from the control room in Kourou, and this is going to be a devastating update because the launch window opens at 10 minutes past the hour, but I'm now being informed that the T0 or launch time is actually not 10 minutes past the hour. It is a whopping 11 minutes past the hour, so the clock is going to gain a minute. There we go. I mean, truly devastating. How are we gonna live with this? But there we go. 11 minutes past the hour, 2011 UTC for the launch of MTG-I2. They have a 2.5 hour launch window to play with today. So should they not be able to launch in 9 minutes time, they do have time in the window to recycle, assuming that everything allows them to do so. But of course, we are hoping that everything remains green for the launch in just under 9 minutes time. From my position here, I'm not going to say I have any numbers on the weather, but it's blue skies, a couple of small clouds, so it really seems well within limits. Of course, we can't see the wind, but fingers crossed there's no upper level winds at play to obstruct a launch in 8.5 minutes time. As we continue to count down here, 8 minutes to go until we see this vehicle ignite. We have another question here from Fred, spelt with PH. I'm shocked that the launcher is so close to the vertical integration building. If there was a rapid unscheduled disassembly on the pad, it would surely damage that structure. Well, Marty, we were talking about this earlier, but it's really kind of a optical, I don't know if optical illusion is the right word because it's just the lens doing this, but that building is actually not directly next to the rocket. We can give everybody a sigh of relief.
From this perspective, it looks like the building is about as tall as the rocket and sitting right next to it. But it's not. It's because of the camera angle and it's probably also some distortion from the lens. And here's actually a picture from Sentinel-1D, which was in 2025, I believe, which actually shows the distance between the rocket and the building. Sure, it's still fairly close for a building that's going to be right next to a rocket launch, but it's certainly not as close as, for example, the 4 towers or the Strongback. So, this building will most likely be safe. And even more so because it's actually designed to be here. They knew from the very beginning that this building was going to be within a few hundred meters of a rocket launch and potential problem with the rocket. So they designed it to be able to withstand whatever happens during a launch, at least. So I wouldn't worry about it too much, to be honest. What we were talking about earlier, and you can actually see that very well in this picture, is that the Ariane 6 rocket is actually assembled inside this building, and then the building moves out of the way. Different rockets do things differently, as we said earlier, and for example, ULA with Atlas and Vulcan will assemble the rocket inside the building and then roll out the rocket to the pad. But in this case, the rocket is assembled inside the building, and then the building moves out of the way just a couple 100 meters to give the rocket space to lift off.
And you could even see there in the picture the rails that they use, which we were discussing earlier. Anyways, we are now getting to the pointy end of the countdown, nearly 5 minutes left to go, and it would be wrong of me to ignore this, but we do have Space Pope in chat, as always. Thank you very much for your support, Space Pope, always helping out the show with a $20 super. Thank you for your support. It is so generous of you all the time. We are very grateful for that, so thank you very much, and always goes a long way to help us keep doing what we're doing, bringing you as many launches as possible. Bringing you launches from more places than just the Kennedy Space Center. As you can see, we're doing our best to branch out as much as we can. We're doing some launches from Vandenberg now. We're doing these launches from Kourou. So hopefully trying to bring you as many launches as possible.
Attention pour la séquence finale lanceur. Top, à 0-5 minutes.
And that is the official call. 5 minutes to go in the countdown. So we are on track.
Very good. That's how we like to see it.
Four minutes, 40 seconds left to go. Once again, thank you so much, Space Pope. It's really, really do appreciate your support there, as always. So, as we continue to count down, that is a live view inside of the Jupiter control room in Kourou. And Marty, I've got to say, for the brief moment we could see it, as we see the thrust vector control being tested on the Vulcan 2.1, that was a very green board. I didn't see any other color other than green.
That was very green, and that is how we'd like to see it. So, yeah, I'm very happy to see that. And I was also very happy to see that thrust vector control test, because it's one of the few views we get of this engine. So always cool to see them broadcasting that on the live stream.
Of course, we'll be getting many, many views as they continue to count down to launch. This one, I believe, from a control room in Europe itself. Of course, the satellite will have its own mission control, as the EUMETSAT will be running that satellite, even though it was kind of built in collaboration with the European Space Agency, who then contracted Thales Linear Space. As we've been talking about throughout this stream, many different stakeholders in a launch such as this. But everybody looking on, I'd imagine anxiously. I've never launched a satellite, but I would have to assume anxiously as we approach 3 minutes to go until launch.
It sure is a moment for the people involved with the satellite and who have dedicated their careers to designing and building and operating the satellite and getting the most out of the data. So yeah, it's anxious moments, but once that's over and once the satellite is in space, they will be rewarded very generously. Absolutely.
2 minutes, 40 seconds left to go in the countdown. You can see that huge flame trench there on the left-hand side from the vehicle, and an extra zoomed-in view as well. I mean, this is even better. You can see the vapor coming off the vehicle, proving that it is indeed alive. As vehicles get fueled, they really do come alive, especially when they have this cryogenic propellant on board, liquid oxygen, liquid hydrogen on both stages of the Ariane 6, in addition to those two P120C solids adjoining the first stage, in the wonderfully offset configuration to the stickers on board the vehicle. I understand, like I say this every single stream we do with the two SRB Ariane 6. I understand why they're offset by 45 degrees, but it's still going to annoy me for as long as this rocket is flying, because the stickers don't line up. They should have just lined up the stickers.
Both. Yeah. They should just have rotated the entire part by about 45 degrees, and then it would have been all fine.
Another view beneath the vehicle momentarily of that Vulcan 2.1 main engine on the LLPM as they continue to purge the umbilical tower behind the vehicle from this perspective. That's what those two big yellow arms are holding the vehicle from. And I believe we are about to hear the final call from the Jupiter control room in Kourou. There it is, French Guiana. So
you can see
it'll be around 60
spectators walking
seconds.
outside.
Yep, as we saw last time. Here we go.
À tous de DDO. Attention pour moins 1 minute. Top. H0 moins 1 minute.
And that is 1 minute to go until launch of MTG-I2. Brand new weather satellite for EUMETSAT. There's all the spectators now outside the Jupiter control room looking on towards the launch pad. And as you can see there, cloudy conditions, but it could be much worse. Still seeing some blue skies in the background. "30 seconds left to go until launch. Getting some wonderful noises from the pad. 20 seconds.
À tous de DDO. Attention pour décompte final. 10,
10 seconds.
9, 8, 7, 6, 5, 4, 3, 2, 1. Top. Allumage des ESR et décollage. La propulsion est nominale. La propulsion est nominale. Le pilotage est calme. Tous les paramètres à bord sont nominaux.
"60 seconds into flight, we can see the launch from the downrange long-range tracking cameras, Ariane 6 in its 2SRB configuration, returning the rumble in the jungle as we now head downrange. We are standing by for the next event in the timeline, which is going to be the burnout and separation of those side boosters coming up in just under a minute. Getting a really beautiful orange plume there from Ariane 6. As it continues to push down range,
Tous les paramètres à bord sont
that
nominaux.
ever-increasing thrust-to-weight ratio.
You can certainly see the differences between the different cameras.
Indeed, and as that plume expands, as Ariane 6 gets higher and higher in the atmosphere, as we said earlier in the stream, we are not expecting any onboard views of launch today, but we do have these super zoomed-in cameras from the ground tracking Ariane 6 as it heads to space. Standing by for separation of those side boosters in about 10 seconds from now. And there we go. We have jettison.
Séparation des ESR.
Confirmation of separation, and we can see them falling away there from the ground. Quite a spectacular view.
Beautiful.
And Marty, it's really clear. The boosters are still streaking because, of course, the propellant is just naturally dirtier. But that one little speck of light, that's a clean-burning Hydrolox engine.
It is, it is. So that's, if I got my chemistry right, it should only output just water vapor and heat. So, yeah, that's very, very clean exhaust, as we expect from liquid hydrogen. And I believe they just said that they're beginning the barbecue roll, which means they're rolling the rocket around to, yeah,
Les paramètres à bord sont
easily
nominaux.
heat and cool by the heat of the sun and the cold of space.
Made famous by the Apollo missions, of course. About 15 seconds away, expected from fairing jettison. Looks like we'll be getting some live animations of that taking place in a few seconds from now.
Pilotage calme.
And there they go.
Séparation de la coiffe.
Separation confirmed from mission control. MTG-I2 exposed to the vacuum of space for the very first time. Next event in the timeline is going to be the Vulcan 2.1 shutting off, the lower liquid propulsion module separating, and then the Vinci 1 igniting on the upper stage. Propulsion continues to be normal from that Vulcan 2.1. Those events expected to take place from 7 minutes and 43 seconds into flight. So we're just over 3.5 minutes from those events taking place. On the left-hand side, of course, we have that live animation showing the position of Ariane 6. Sounding like all parameters on board the vehicle looking good so far. The bottom right view is the live track of the position of the vehicle, and on the top right we have the altitude and velocity. Or the altitude and time, rather. I suppose you can get the velocity from that. And we have the live telemetry in the middle as well. 136 kilometers in altitude, almost 2.5 kilometers a second. Approaching 5 minutes into flight.
Sorry. I do like to point out that even though the fairings have already separated, it's still all attached to the core stage. So the stage that ignited just 7 seconds before liftoff. That's very different from many other rockets we see, like Falcon 9 only separates fairings after second stage ignition. So it's different rockets doing different things, illustrated beautifully by this process.
Pilotage calme.
And you can see the distance now from Kourou. I mean, it launched 5.5 minutes ago. It's already nearly 500 kilometers downrange over the Atlantic Ocean. As a reminder, we're launching pretty much straight east. This is going to geostationary transfer orbit. So we want to be as close to the equator as possible. And thankfully, Kourou's positioning 5 degrees above the equator is perfect for that. And of course, Marty, because they're going to the east, they are flying over the Atlantic Ocean. So not a lot to see on the ground from these animations.
No. And for the first stage of the flight, there's also nobody on the ground to see the rocket fly. Which is, I guess, the same thing, but just phrased differently. But sometimes, especially for like some Starlink launches, I believe, if things line up just right, you get to see them over Europe after a few minutes. But well, definitely not for the Starlink launches coming up, because they're launching completely different trajectories.
They're launching from Vandenberg, so good luck seeing that in Europe.
Yeah, that's it won't really work out that well. But yeah, I've actually heard people seeing the launch on their TVs, computers, whatever, and then walking out to see the Starlink train come over just shortly after deployment. Unfortunately, I've never managed to catch the timing like that, but it sounds very cool. It's not happening for me this time, but maybe for some people watching from Africa. Still nominal, sounds good.
Indeed, that's what we want to hear. We are approaching engine shutoff with the Vulcan 2.1. And then we will see stage separation. I stand by for that call.
Extinction Vulcan.
Bit close to the microphone that time, but it's okay.
Séparation LLPM. Acquisition par la station natale.
Okay, so we've got good shutdown of the Vulcan. We have good separation of the lower liquid propulsion module. That's the booster. That is now falling away to end up as a new reef in the Atlantic Ocean. We then heard acquisition of signal with a ground station, probably Ascension Island or Natal, if I had to guess. And then good ignition, as we heard there. Propulsion is nominal on the Vinci 1 upper stage engine.
Yes, Ascension Island will be next. They're currently connected to Natal.
Okay.
But it's it's just all an animation, so of course it's going to look good. But from the call outs, it sounded good, and on screen it looked good as well.
Indeed. I do know some people were wondering about the I do know some people in chat were wondering about the onboard views. Of course, as we were talking about, there are no onboard cameras on board this specific vehicle. Now, that isn't a ground station problem because they are, of course, connected to Natal and they'll be up connecting to Ascension Island next. But the vehicle is either not fitted with the cameras or they are just not dedicating any bandwidth to the cameras. So Arianespace obviously deciding no cameras on today's launch, headed straight up to geostationary transfer orbit. Approaching 10 minutes into flight. And Marty, this burn on the Vinci 1 is expected to go for quite some time.
It really is. Like, they ignited at almost 8 minutes into flight, and then it will just keep burning and burning and burning until T plus 21 minutes and 28 seconds. So that's pretty much like 13.5 minutes.
And you can see there on the right hand. We'll go on.
It's a very low power burn, but that also helps insert the payload into a very specific orbit. Like, they don't have to get the timings very precisely because they can just slowly inch up to the correct orbit and then shut off the stage. Whereas by Falcon 9, which has a very powerful upper stage, they have to get the timings very, very precisely to perhaps within milliseconds, or else the orbit won't be as precise and the satellite will have to compensate for that throughout its life.
Indeed.
They do it, but it's just a different strategy.
And we can see, thanks to that graph in the top right, propulsion continues to look good. The difference in gained altitude over time, of course, gaining a lot of altitude very quickly with those SRBs, then gaining a little bit less altitude with the lower thrust LLPM, the first stage booster, and then gaining even less altitude with the low thrust upper stage. But it's low thrust but very efficient, at least in terms of chemical rocketry. Of course, this is Hydrolox, which means that it's hydrogen is very undense, whatever the opposite of dense is. Sparse.
And sometimes in these graphs, you can actually see that they lose altitude for a while during the burn, just to get to the right orbit. And that's just part of making the burn line up precisely so that they get into the right orbit, because up until Ariane 6, the upper stage didn't have the ability to restart. So unlike a Falcon, which can do a short burn to get into a certain orbit, then wait for a while, and then change its orbit, Ariane 6 can do it, but they often still choose not to, and then you get all these weird things where they slightly descend during the burn on the way up. But whatever gets them in the right orbit, it works. It's orbital mechanics and mathematics. Works out very well, even though it might look a bit odd.
Trajectory continues to be normal, so there's your answer. Everything looking good. 9 minutes left on the Vinci engine on the upper stage there. Currently approaching 13 minutes into flight. So a much longer burn than you would expect, for example, from a kerosene rocket like Falcon 9, or a methane rocket like Starship. Burning all the way to the geostationary transfer orbit on the very first burn for this upper stage.
La propulsion est nominale.
And nominal orbit for this burn should end up at 250 kilometers by 35,666 kilometers at approximately 6 degrees of inclination. They're not there yet, though. So about 8 or 9 more minutes to go.
Slow and steady wins the race. Although maybe that's a bad analogy for Europe because we're quite far behind. Okay, we can edit that bit out. We'll edit that bit out.
They're trying to catch up though, and spoiler for tomorrow's This Week in Spaceflight, they actually have some exciting news when it comes to catching up.
Indeed, some new contracts, but to get the details on those, I guess you'll just have to tune in tomorrow night. It's the only plausible option.
For sure.
Now,
It was a
6.5
fun story to write,
kilometers
though.
per second in speed, 230 kilometers in altitude, nearly 3,000 kilometers downrange.
Ascension.
And there we go, acquisition of signal on Ascension Island. Sorry, Marty, I cut you off.
Le pilotage est calme.
I was just talking about having fun writing a story for This Week in Spaceflight, so I guess the actual launch we're looking at is more important.
Launch is pretty fun.
It's pretty fun too, for sure. I mean, I wish we would have live onboard views, but still, the view we got at liftoff, like Ariane 6 leaping off the pad and then doing that very distinct pitch over maneuver, was a very impressive view, and I always love to see it, even if we just have to resort to the
Changement de
animations at
régime
this point.
Vinci. Propulsion nominale.
15 minutes into
Pilotage
flight
est
now.
calme.
Continuing to burn on the Vinci 1 engine on that upper stage. And that will continue burning, as a reminder, until 21 minutes and 48 seconds into flight approximately. And you can see there on the right-hand side, the top right, I should say, the graph is now expanded. And you can see after this little dip in altitude we're in now, it'll actually start to pick up again as the vehicle continues to gain velocity, because eventually we're going to be heading up beyond 30,000 kilometers, let alone 300.
Yeah, and what you can see is like the green trajectory, the green line is the trajectory the rocket should be following. And then the yellow line, which overlays perfectly, as it should, is the trajectory the rocket is actually following. So as long as these lines are the same, then we're all fine and happy. And as soon as they start to diverge, let's hope not, but then we've got some problems.
And we just heard from the Jupiter control room in Kourou that the propulsion is continuing to be nominal and we are now in orbit. So if this was a low Earth orbit mission, they could turn the engine off right now. But because we're going straight to a geostationary transfer orbit, we are continuing the burn until 21 minutes and 48 seconds into flight. Everything continuing to look good. Yeah, we're now 7.5 kilometers per second in speed. So they could definitely turn off the engine and stay in orbit, but that wouldn't be good for the payload because that's not where they want to be. They want to be in geostationary transfer orbit. So we're continuing the burn for 5 more minutes.
Slow and steady.
And we should shortly begin picking up altitude once again as we exit that kind of slump in the burn. So we're now over 4,000 kilometers downrange from Kourou.
La propulsion est nominale.
Almost directly to the north now of Ascension Island in the Atlantic Ocean. Approaching 8 kilometers per second in speed.
Tous les paramètres à bord sont nominaux.
Everything continuing to look nominal on board the vehicle, which is what we want to be hearing from Mission Control. Vinci 1 continues to burn on the upper stage. And we can see now in the top
how
right.
stark that increase in altitude will be.
Exactly, and it's just popped up as well where the Vinci engine will be cutting off. It says Extinction Vinci. That is where that engine will be cutting off, really, as it starts to hockey stick up. Because, of course, it needs to do that if they want to end up in GTO.
It should, because the trajectory it will be left on is 2.5. The orbit will be 2.5. Let's try that again. 250 kilometers by 35,666 kilometers. So that is a very elliptical orbit, which you can actually see in this hockey stick graph.
Tous les paramètres à bord sont nominaux.
As expected, everything continuing to look good. 18 minutes and 55 seconds, 19 minutes into flight, almost. And yeah, we can see in our altitude very much picking up the pace as we go 227 kilometers, 228 now, over 5,000 kilometers downrange from Kourou. Almost 8.5 kilometers per second in velocity. And despite us approaching 20 minutes into flight, the burn is not done. We are still burning. And this burn will continue until almost 22 minutes into flight.
Could have launched 2 Falcon 9s in that time.
La propulsion est nominale.
We're almost over the coast of Africa. And we left French Guiana on a different continent 19 minutes ago. This thing is really picking up the pace.
Acquisition par la station Libreville.
And we've got an acquisition of signal with our first ground station in Africa on the mainland. I'm not sure if Ascension Island counts as Africa. It's kind of in the middle. But here we go, 250 kilometers in altitude now, 9 kilometers per second in velocity. Almost 6,000 kilometers downrange. And you can see in the animation there, Africa in the background. And yeah, that top right graph is just ticked again. And it almost makes the initial ascent from the SRBs and the booster look like nothing, considering how much that line starts to increase over the next few minutes. Propulsion continues to be nominal.
From a point, that marker of extinction of Vinci, when the Vinci engine will cut off, it will just follow a normal orbital trajectory all the way up to 35,666 kilometers, which is just the path that it will be left in. And then
9.5 kilometers per second.
Ooh, we've almost got caught up.
Fin de visibilité par la station Ascension.
No, Ascension Island can't see the vehicle anymore, and we did hear that they have ended the barbecue roll on the upper stage. And there we go. Upper stage engine has cut off. I think the animation needs to get the memo.
Time to update the animation, I think.
Yeah, I'm not sure there we go. Thank you, animation. But of course, these decisions are made by... Did he just say that propulsion is nominal, even though the engine was cut off?
Huh. I hope that was just a mistake.
Le pilotage est calme.
Okay, well, let's assume that everything is fine. I completely forgot what I was saying now. Oh yes, the decisions are made by the vehicle itself. They have a timeline before the launch, of course, but the vehicle will be adapting in real time to its situation. So obviously the rocket's not going to do something. The rocket is going to do its part to get to its destination, not just follow a specific timeline set out before launch.
Exactly. And of course, as Peter is pointing out, if the propulsion is off and it was supposed to be off, it is nominal.
I suppose that is true.
Just a weird way to say that. But now we should have about 15 minutes until payload separation.
Le pilotage est calme.
And
indeed.
Then, the MTG-I2 satellite will start commissioning itself, deploying its solar panels and all that. And it will also raise its own orbit to the full geostationary orbit
Tous les paramètres à bord sont nominaux.
It's supposed to operate from.
Just hearing that the trajectory is nominal and all parameters on board are nominal. So we will continue coasting until separation. That's scheduled for 36 minutes and 28 minutes into flight. But as I was literally just saying, the vehicle will do that when it sees fit. We have gotten some support and some questions in chat. So I think now is a relatively quiet time in flight to go over those. First of all, thank you very much to Space Pope doing more support, if you can believe it, gifting 20 Red Team memberships. So if you received one of those, make sure to thank Space Pope in chat. That is greatly appreciated. We also have John Mr. Coffee. Thank you.
Vinci. Fin de compensation de l'APU.
Well, they just said Vinci extinction again, and I thought that happened like 3 minutes ago. So I'm not 100% sure what's going on, but they don't sound concerned.
They said something about the APU.
Yes, maybe the APU was burning or something.
Yeah, or they extincted it. Extincted? Well, whatever.
Extinguished.
Extinguished. That's the word. Thank you.
Looks like we're getting another ground station on the animation, but nothing cooling out. Good timing. So that's another ground station acquired. John Mr. Coffee, this is for Sawyer Giants. I'm going to assume that's some American football reference or American baseball or something. I don't do American sports. I don't do sports in general, let alone American sports. I do apologise, but thank you, John, for your support, as always. Always great to see you in chat. Bideford, of course, Bideford's always in chat. Thank you very much for your support. New contracts for whom? Well, as we were saying, you're just going to have to watch This Week in Spaceflight tomorrow night, and then you'll learn all the details about some European launches that might or might not happen before 2027.
2028. But don't spoil.
Oh yeah, 2028. Sorry, it has to happen in 2027, so it's before 2028. I still have to get my head around that. But anyways, Bideford, thank you very much for your support as always. Marty, we have been getting several questions about the second stage because, of course, the payload deployment is not going to be the final event for that stage in the timeline. Derpinator is asking, will the second stage be returning? Does it burn up or is it space junk? We also have FWB79 asking, will the second stage be returning? Oh wait, no, I've lost it. Will the second stage eventually crash and burn? No, it's an interesting way of phrasing it. Do we know what's going to be happening with the upper stage? I would assume because it's going to a GTO, it will probably be going to a graveyard orbit, but I don't know. I suppose it doesn't have the propulsion to burn for a graveyard orbit, because if it did, it would be delivering the payload to Geo and not GTO.
Yeah, so the upgrades introduced on Ariane 6 actually means that if needed, they could do a disposal burn, because now with the APU, auxiliary propulsion unit, or sometimes also referred to as auxiliary power unit, actually helps the stage relight if needed. But I don't believe it's going to do that for this mission. In fact, Arianespace said that it's at about 1 hour and 40 minutes into the flight, it will start the passivation maneuvers for the upper stage. So that means that they're going to dispose of the final propellant and all that stuff left inside the stage and make sure that it's a passive object and that if something happens with it, it's not like a ticking time bomb or something. So, apologies. But I think it will be coming back quite soon because the stage will actually be left in like a 250 by 35,666 kilometer orbit. And that 250 kilometers on its perigee is so low that it will come back within not too long, if not weeks, maybe days, maybe months. I'm not quite sure how long it will take, but this thing won't be up there forever. But like you said, Ryan, if it did actually deliver the satellite into geostationary orbit instead of just geostationary transfer orbit, then it would have to use that APU to relight and put itself into a graveyard orbit or something, because it probably wouldn't have the power to come all the way back down. But for now, it will probably come back down just by being decelerated by the traces of atmosphere that will be left at 250 kilometers in altitude.
Continuing to coast here, 28.5 minutes into flight. Severin Fisher is asking in chat, And I've done maths here while you're answering your question, Marty. So we'll see if I'm right or not. But they were asking, is it possible for Ariane 6 to launch with no SRBs at all if the payload is light enough? I'm pretty sure earlier in the stream we established that Ariane 6, this configuration was about 500 tons. And according to Avio's website, each P120C is 153 tons. So I subtracted that from 500 to SRBs from 500. And then I multiplied that by 9.81. And then I did the thrust of the Vulcan 2.1, which is 1,370 kilonewtons, divided by, or was that in newtons? Maybe I've done my maths wrong. I think the thrust to weight ratio would be about 0.7. So, no.
It will first burn through a lot of propellant and then try to get off the ground.
I've had many Kerbal Space Program rockets like that in the past, in which case my solution was add solid rocket boosters. So they do serve a purpose, it turns out. SLBs are quite good at providing good bang for your buck, good thrust for your buck.
The goal is really to get the rocket up into the air or up into space a bit and then let the core stage take over propulsion.
Indeed. We were saying earlier in the stream, we saw it very clearly on the last flight with the upgraded P160Cs, and they had 4 of them. And if we saw it on this flight as well, the plume generated by the SRBs is really clear. You know, that thing leaps off the pad, and then it immediately does its gravity turn to head out over the ocean and head down range to pick up as much horizontal velocity as possible. So it's really quite impressive how quickly that thing does a gravity turn, especially with the thrust of those SRBs.
It really is. And I'm always surprised by how stark that gravity turn is. Like, you could see it at liftoff just half an hour ago. Like, it went up and then almost immediately it went slightly sideways. Very clear for Ariane 6. Whereas with other rockets, it's usually a bit more gentle. But it doesn't matter. It gets them there.
Indeed. Okay, we have just crossed 31 minutes into flight, and this means we are coming up on payload separation. As a reminder, that is scheduled for 36 minutes and 28 seconds into flight, so in just about 5 minutes from now.
Tous les paramètres à bord sont nominaux.
Sounds like we just had another call related to the ground stations, but everything continuing good on board the vehicle. But we can look at the altitude now. We just crossed 1,700 kilometers in altitude. We're 11,100 kilometers downrange from the launch pad. And of course, we're at 8.5 kilometers per second. And that velocity, Marty, will continue to tick down. But that's not a bad thing. That's just because I'd say if you imagine throwing a ball in the air, as it continues to rise into space, it's eventually going to be slowing down.
Exactly. Yeah, it's just gravity. Just the stuff we're used to on the ground when throwing stuff in the air, like you said. But then imagine it like traveling all the way around the Earth and coming back. So, yeah, I mean, that doesn't really help you visualize it, but it's the same mechanics at work. And I just noticed, Ryan, earlier we were just after upper stage extinction, we were talking about that they were mentioning the APU, and now in the graph in the upper right corner, it says extinction APU. So I suppose that they're like either currently burning that APU or that they will start burning it shortly. It's not on the official timelines for this mission, so I'm not quite sure what they're doing with it, but I'm sure it serves a purpose.
I'm sure it would say ignition if it was startup, because that's what it says for all the other engines. So I'm gonna, maybe they are burning it right now to generate electricity. I don't know.
Maybe.
But we are approaching 33.5 minutes into flight, so we're about 3 minutes away from stage separation. In the background there, you can see the Horn of Africa, the Middle East. We've got India in the background as well on the live animation. As we head over the Indian Ocean. Wonder if they'll catch a view of Ship 40. Who knows? Oh, look at that. That's an even nicer animation. It's a good visualization, for a moment at least, of just how high above the Earth. Just high above the Earth that the vehicle now is compared to, your average 200, 300 kilometer parking orbit for a Starlink mission that we're very used to these days, of course. And that call out was just the vehicle getting ready for the separation of MTG-I2, the payload for today's mission. Brand new meteorological satellite for EUMETSAT, helping to improve the weather forecast and track storms in Europe and North Africa. That separation should be coming up just a couple minutes' time. Well, we have a couple minutes, Marty. Duncoding is asking, is Ariane 6 crew rated? That's a good question. Right now it isn't, but there have been concepts, and I will call them concepts. Whether they actually happen or not is another question entirely.
There certainly have been concepts. And I believe it's still something that ESA is not ruling out. Like, the European Space Agency isn't currently working on any crewed missions, but they might be in the future, and then they might also want to crew rate Ariane 6. So it's still on the table, but at this point it seems unlikely.
Never say never, but yeah, it does look like some other vehicles might get there before Ariane 6.
For sure.
There we go, 35.5 minutes into flight, about 1 minute away from payload separation. And that's going to be a very exciting event as this satellite heads on its way.
Le pilotage est calme.
Of course, this payload inserted into a geostationary transfer orbit. This means that the satellite itself will have to do its full circularization to insert it into its geostationary orbit. Sounds like the APU is now shut down. And we are just seconds away from payload separation. Standing by for the callouts from the Jupiter control room in French Guiana. Should be happening any moment.
Séparation MTG-I2.
And there it goes. Confirmation of separation of MTG-I2.
Applause. Well, that's what we like to see. Nominal mission from what it looks like, nominal separation. All very good.
Trying to work out if there'll be any more sound or if they'll just have the microphone on by accident.
Might be the latter.
Confirmation de la bonne séparation de MTG-I2.
There we go, confirmation of a good separation. More applause.
It's worthy of applause. Ariane did his job very well. So now it's up to the satellite to get all the way there and perform its mission.
In the meantime, Marty, this is, of course, it's not going to be the final launch of Ariane 6. When is the next one? And what's going to be on board, if I could be so cheeky to ask?
Of course, the next one will be coming up in, I'd say, just over a month. It's scheduled for October 7th, and it will be an Ariane 64 launch. So the rocket's most powerful configuration, probably also with its 20-meter fairing. So yeah, it's really the maxed out configuration with Block 2 P160C solid rocket boosters as well, 4 of them. And they will all be needed to launch a batch of Amazon LEO satellites. So internet satellites for Amazon's LEO constellation. All coming up on October 7th.
There we go. 3,300 kilometers in altitude now, which is, as you can see, it's getting up there. It's getting up there. Payload now deployed as we fly over Australia, pretty much, or north of Australia, I should say.
10% of the way compared to.
Yeah, that's a good point. It is only 10% of the way.
It's all the way up there, but it still has a long way to go.
And it looks like we might be getting some words now from the CEO.
The satellite has been perfectly and we are delighted. My first thoughts, of course, are for our client, EUMETSAT. Thank you so much for your trust. Thank you so much for your support. I also would like to thank all our partners, the European Space Agency, the CNES, Arianespace, OHB, and all the other stakeholders. Of course, I would like to thank all the team involved. Once again, you have demonstrated that hard work, dedication, and passion leads to outstanding results. Thank you so much.
It certainly does, David. Thank you very much indeed, and congratulations to you and to all the team. David, thank you.
And there we go. Final words from the Chief of Arianespace. One more note I will say is that tonight is, of course, the lunar eclipse. It's not a total lunar eclipse. It's a partial lunar eclipse, but it's a pretty substantial partial lunar eclipse. And if you happen to be in Europe or Africa or South America or North America or the Pacific Ocean or the Atlantic Ocean, basically, if you are watching this stream right now, which is where the majority of our audience is from, do go outside tonight and take a look at the moon if you can, if the weather cooperates. Marty, will you be trying to see the lunar eclipse?
I will at least try it. It's going to be very low to the horizon, and I don't have to go to bed very, very late or wake up very early because it's at like 6:15 here. Yeah, I think I might give it a go and try to get out to a place where I have a clear view of the horizon and just watch the maximum eclipse just above the horizon, just before moonset.
I was going to, but the weather forecast is very much cloud for the foreseeable future. So unfortunately, I very much doubt I'm going to be able to see anything, unfortunately.
You're raising a good point there, Ryan. Like, I didn't think about checking the weather forecast, but I might before setting an alarm.
Yes, I don't exactly want to get only a few hours sleep just to wake up and look at some clouds, because I can see clouds anytime I like, because I live in the UK. So, yeah. That one we'll just have to wait and see. But if you are in a location with good weather, do take a look at the moon tonight. Figure out what time it is. Just Google it for your location, and the moon should be a blood red, which I'm sure will be fascinating to see if you do not have clouds like we do in the UK. Anyways,
they're always very beautiful.
Indeed.
Definitely do recommend.
Absolutely. I also recommend the clouds get out of the way, but unfortunately I don't believe I'll have much influence over that. And with that, Marty, thank you very much for being on today's stream.
Thank you for having me. It was a lot of fun to see this Ariane 6 launch, as always, and it was a lot more fun to talk to everyone, answer the questions, and yeah, just be on here. So thanks for watching, and I'll see you the next time, but over to you, Ryan.
Indeed. Thank you very much. I've been Ryan Cater for NSF. Thank you to everybody for watching, for commenting, for questioning, for super chatting and all the things. Very much grateful for all of your support. And we will see you next time. Bye-bye.
And here we go.
There's the W. Here's ignition.
Traveling up.
Did you just do a Kerbal?
Back to the moon and beyond.
Put that in the big bag, you know.
Back at home, we all have a lot of work to do, but from here, that sure looks like a perfect flow.
Propulsion continues to be normal.
We did have an observation.
343 unfolds to go.
It's orange.
Water towers can fly!
Bingo! Right in the center.
Where's Jacqueline? There it is!
so surreal.
That's not what we want to see.
No.
Oh my god.
Yikes, you bet. We don't need any more of these.